Ladies and gentlemen, button pushers and wrench turners, welcome to another episode of Something's Broken. My name's Taylor Goodyear, and I own TG CNC Service out of Wisconsin. This past week was a good week. A lot of positive things happened, which makes me happy. Monday, one of my local customers hit me up. They have a MV40 mill with Yaznak control. And I don't have a lot of experience with Yaznak, especially this old of a machine. So already I was kind of a little checked out on it. They had the OEM in a couple times and they couldn't figure it out either. So I wasn't very hopeful when those types of jobs come around. I get a little nervous. But some positive things came out of it. So, just a little history on the machine. I don't know how, but the machine ended up losing everything. Lost its memory, lost parameters, lost its ladder, lost everything. The customer had Yaznak in, had the OEM in. They got everything into the machine. The Yaznak guy pulled parameters from not the same exact machine, but a very similar machine. So we think that the ladder wasn't the same. Now, this machine has a pallet changer, and from what I understand, the Yaznak tech put in parameters and ladder from a machine that didn't have a pallet changer. So we think there's some logic there that we were missing, but the ladder on the machine is all in Japanese. So I can't read the ladder. And I don't know what the parameter is to change it. So anyways, the customer couldn't get the right M code to fire on pallet change at the end of a memory program. So what they were trying to figure out now, M61, 62, 63, and 64 were all the macro M codes for firing pallet change. Now it has two station pallets, so you have A and B, and at the end of the program, before everything was lost, M02 would read and fire, and then that would send it into a macro program to change out the pallet. Now the ladder would follow the logic of the pallet, so the ladder would know what the work number was of the pallet that was in the machine when the program stopped. Now I think in theory what happened when the machine lost everything, we lost the rungs that held the logic for the pallet that was inside of the machine at the end of the program. So every time that we tried to get the machine to read M02, it would want to double stack the pallet on the pallet that was already in the waiting station. I tried to get into the ladder and try to figure out why it was reading that logic and what wasn't holding, and it was all Japanese, so I couldn't read it, and I couldn't use my phone because the display unit was so old that my phone wouldn't pick up the digital readout on the screen. So I couldn't even do that. So I was like, okay, well, I'm kind of fucked. But I did a little reading. I did a little investigating into some of the books that they had there. I found a specific manual for the pallet changer, and inside that manual there were a set of parameters that you could fuck with to get either M02 to fire at the end of a program, and it would hold the logic and pallet change according to whatever pallet was inside the machine, or you could change some parameter settings and fire M61, 62, 63, or 64. And each 61 would be its own macro for pallet change, 62 would be its own macro for pallet change, yada, yada, yada. 63 and 64. So I kind of fucked around with that, and the customer was able to rewrite the macro programs inside the controller to read M61, 62, 63, or 64 at the end of the program instead of using M02. Now, the trade-off to that was now he has to longhand the second pallet operation. Now, what I mean by that is you have your full operation in the program for one pallet, right? And now instead of M02 re-looping the program, now he has to have its program, M61, swap the pallet out, bring the other pallet in, and then longhand the same program in the same program list and run it again. And then at the end of that, then he can M62 and send it out and bring the other pallet in. Are you creating a lot more work? Maybe not a lot more work, but the fact that you have to longhand the program twice inside of the same program, it's kind of tedious, but we found a way around it and we got it to work the way that we wanted it to work. So I don't know what the fuck I did, but we got it to work and my customer is happy. He's like, all right, I can work with that. I was like, okay, perfect. So I don't know. Sometimes you get lucky like that, fucking around with shit, and you start changing parameters and stuff, and you somehow get things to work the way you want it to. Now the parameter that I changed was, I'm probably gonna butcher the fuck out of it, but I'm gonna try to explain it as best as possible. So the parameter was 799.5, I think it was. 7995 bit 5. Bit 5 was confirming that M02 would pallet change and re-loop the program, and M02 would fire 61, 62, 63, or 64. I turned that off. And when you turn that parameter off, it gets rid of M02 logic completely in the ladder, so it won't even read M02. It'll alarm out right away. It diverts back to having M61, M62, 63, 64 being read in the actual memory program. So I'm pretty sure that's how we were able to get M61 through 64 to work the way that my customer wanted it to work. So just a little explanation. I don't know shit about Yaznek, so don't ask me. But somehow I was able to figure it out with just doing a little bit of reading, opening a book, and going from there. So I'm happy. Customer's happy. Machine's running. It's all that matters. So next was, I had a new customer reach out to me. That Monday, I believe it was, when I was at this customer. Called me up and, just kind of said, hey, we, local machine shop, we want to bring you in and do a walkthrough and possibly use you for service in the future. I was like, fuck yeah, man. When and where? So Tuesday we set up the meeting and I did a walkthrough. They have all Mazaks, which is great. Great for me. They have a DeVlieg jig bore. I think they have a VTL, like an old mechanical VTL, and I don't know what the brand of it was, but it's a pretty good size VTL. And then they had another manual machine, but I can't remember what it was. So they have, all in all, I think they have 8 Mazaks, different, that horizontal turning centers, a couple of verticals, relatively newer Mazaks as well too. So the walkthrough was great. The contact was awesome. Dude's awesome. Sounds like we're probably going to be working with each other quite a bit in the future. They just got tired of using the OEM service, and it's getting more and more prevalent that is becoming a problem for customers, whether it's response time, lack of knowledge, or price point. They're just too fucking expensive, man. And I think that's where I'm able to come in and still have the quality service for a considerably cheaper price. And just because somebody's cheaper doesn't mean that their quality of service is any less. So I don't want anybody to get that mindset that just because my rates are low doesn't mean my quality of service is low. Quality of service is what keeps customers coming back. So your price point gets your foot in the door. Your quality of service keeps them calling you back. So we solidified that. I have my contractor's going in there next week, Tuesday, to do some work on one of the Mazaks. So we're already starting to do work, and it's going to be great. They don't have an in-house maintenance team, so it sounds like any kind of like thing that happens on the machines, they reach out to outside service. Now, the great thing about my company is I just don't work on one type of OEM. I work on damn near whatever the fuck you got in your shop. So, I think it's going to be a lot easier for them to just call me in the future for any issues on any of the machines, not just like Mazak or Devleek or whatever the fuck the VTL was. But now I think it's just going to be a lot easier, and I think customers like that. I think customers like when they can call one person for any machine. Why wouldn't you like that? I mean, you cut out so many lines of communication, and not only that, but I hear OEM communication is getting worse and worse and worse. It's not just one OEM. It's you're going down the line, and the communication, like, nobody's there to pick up the fucking phone. And it's like, well, if you offer a service and you're not answering to provide a service, eventually people are just going to start knocking on somebody else's door, And I think that's where OEMs and third parties clash, man. But hey, I'm here to catch whoever doesn't want to fucking work with the OEM. So, it is what it is. And I'll tell you what, man, I'm gonna do whatever I can to support them to the best of my abilities. I mean, it's that's part of my passion. It's just the way I operate. So, I think there's gonna be a lot of good work that comes out of between my company and the new customer. So, excited for it. Ball screw on a hard inch, super precision. Man, this job has been a fucking shit show, man, from the very start. First off, it took like 5 or 6 months just to get the ball screw in. We get the ball screw in, and I go to grab the ball nut, and I have like this back and forth like slop without any preload, and I'm like, what the fuck? And I talked about this on the last episode. I hit up my buddy in Michigan at Robert's Ball Screw, Joe Powell. Hit him up. Dude's the shit when it comes to ball screws, and I got his advice, and he told me straight up, man, like what it's called is called dead bend, and it's not good, but it's not the end of the world either. So we got a hold of the OEM. The customer sent the What's really weird is the OEM admitted at first that there was something wrong with the ball nut, right? Okay, we all know that there was something wrong, right? Customer sends the ball screw. They do an evaluation. They come back and they tell us, no, there's nothing wrong with the ball screw. I'm like, well, somebody already stuck their foot in their mouth and said that there was something wrong with the ball screw when we sent the video of what was happening. But now all of a sudden there's nothing wrong with it. So my customer basically wheel and dealed with them and was like, okay, here's what we'll do. We'll accept the ball screw back. We'll have our technician, me, put it in. And if there's any problems with the ball screw, you guys will take it back free of charge. And they agreed to it. Cool. Covers my ass if anything happens. But it also covers the customer if anything happens to that ball screw. Now the customer's not out $5-6 grand or whatever, however much the fucking ball screw was. Now we have the OEM backing the ball screw, which is good, regardless of whoever's putting it in. So for anybody that doesn't know, if you buy OEM parts and it's not the OEM that puts the part in the machine, 9 times out of 10, they will not warranty the part. That's just the way OEMs operate. So there becomes kind of a gray area, and it becomes more pressure for the third party to be good at what they do, because if I go to put in, let's say, for an example, a new ball screw, and I don't stretch it right, or I over tighten bearings, or that thing like doesn't get proper lubrication, anything, and that ball screw gets smoked in 6 months, the customer's coming back to me and asking me like, "What the fuck, man?" Now I have to cover it because the OEM's not going to cover it because I'm the one who put the ball screw in. So there's a lot of pressure behind third party service when you're putting in OEM parts because you don't get the OEM to back you like if you were actually working for them. You know, if you were a service tech working for the OEM and you fuck something up, the OEM just wipes it and sends another one, right? Just slaps you on the hand, tells you, you know, did you figure out what you fucked up on? Yeah, I figured it out. Done. That's it. You move on. For third party, you don't get that luxury. And when you smoke something like that, a ball screw or a spindle, worst case, that's a lot of fucking money that has to come out of my pocket to, you know, replace what I fucked up. So there's pressure behind being third party, man. It becomes stressful, honestly, because it's not for everybody to do that, to be a third party and go out on your own, because if you make one mistake, man, it could make or break you as a company, and it's scary. I mean, a lot of jobs I go on like that. Now there's some things that I won't do because of that, because the risk to reward ratio is not, they're not even close to each other. And if I think the risk is going to be completely greater than the reward of doing the job, I won't do the job. I will tell the customer, pass it off to the OEM, and I'm not touching it. So you got to pick and choose. You know, you got to pick and choose your battles sometimes. So got the ball screw in, got everything. Now this ball screw is floated in. It's not a lot of times that I've done a floating ball screw, and what I mean by that is neither the fixed bearing end, or the floating bearing end, or the support end, whatever you want to call it, neither are pinned. So that means they're pinned in place this way, but they're not pinned this way, if that makes any sense. So you have the ball screw and you have the support ends. They're not captured this way. They're just captured stationary, like the blocks themselves are captured. But this setup, the support end is completely floating. It's not pinned, nothing. The fixed end is captured relatively okay, but they have this. They don't have dowel pins, two dowel pins. Usually, dual dowel pins, help keep your bearing block straight this way. Instead, they just have a big fucking pin right in the middle. So that only captures your center line, but that doesn't capture the actual parallelism of the ball screw relative to the whatever axis that you're doing it to. So it's floating basically. So you have to float them in parallel to the axis that you're doing the ball screw on. Now, I made a little bit of mistake. Not much of a mistake, but I didn't do what I knew I needed to do, and I'll go into it. So I checked parallelism of the ball screw relative to the z-axis, because it was a z-axis ball screw on a lathe. So I checked parallelism, and I was within 10 microns across like more than half the stroke of the ball screw. So I was okay with that. That told me that the fixed end bearing block was relatively parallel with the z-axis. So the floating end, I basically just like kind of kept the floating end loose. And usually what's a good rule of thumb when you're doing ball nuts and you tighten ball nuts to the actual casting, you want to run the casting all the ways as close as possible to the fixed end bearing block. And then that's where you tighten the ball nut. You don't tighten the ball nut to the casting in the middle of the ball screw, because you have droop in the ball screw, and also parallelism could be off as well too. So then when you run the turret to the actual fixed end or the floating end, you start to hum, and you see your load kind of fluctuating up and down like that. That's because parallelism isn't straight, and you captured the droop of the ball screw and not the actual true parallelism at the fixed end. Now it's always going to be tighter at the fixed end of the ball screw as far as like parallelism goes, right? So what I did, I did exactly that. I tightened the ball nut in the middle of the stroke just to capture the parallelism, and then I ran it to the fixed end. Double check parallelism as best as possible. They don't give you a lot of room, and I was relatively straight. So when I did that, I didn't loosen the ball nut and then retighten it close to the fixed end. I didn't do that. I should have did that. I ran it down to the floating end, and then I ran the ball nut as close as possible to the floating end, and then tightened and torqued the floating end to capture the bearings on that. Thought everything was good. Now, this machine was throwing an excess error, which, with my experience, excess errors on FANUC controls is mechanical loss of the ball screw. So I originally diagnosed, I loosened the ball nut from the actual turret casting, and I just gave it a turn, and boy, was it grindy, loose, zero preload, everything like that. So I was like, all right, ball screw shot. Anyways, so once I captured everything, tightened everything up, we had a lube cycle kind of that was already in the controller, and all it does is just like move the X and Z and whatnot for however long you want to run it for. So we ran that lube cycle, and this is a manual lube machine, so they have grease zerk blocks. So I gave it a couple pumps into the ball nut, ran it, gave one more pump, ran it again, and then we turned it up to rapid, full rapid. We ran that for about 20-30 minutes, and then one more pump. Done. During the rapid, now the customer couldn't rapid before. As soon as they would rapid, boom, they would alarm out for excess error. Well, we made it through no problem doing rapids. So I was happy. I was like, okay, it definitely was the ball screw. So I leave. The customer sets up the machine. I leave. Everything's good. I leave, and customer calls me at like 5:30. I was like, good news or bad news? He's like, well, when the turret gets really close to the spindle to cut off, it starts vibrating. I was like, god damn it. Fuck. I told him, I was like, hey man, that's my fault. I was like, I know exactly what happened. I'll be in the morning. I apologize. And I kind of explained to him like what happened. So I go in and I fix it. I run the turret to the fixed end, loosen the ball nut, retighten it, boom, vibration goes away. Run it all the way down to the floating end. We have vibration, so my parallelism was off. So I loosened the bearing housing and recaptured that. Boom, goes away. So we go back to running the lube cycle, ran it, yada yada yada. They run parts, everything's good, load looks good, nothing's fluctuating or fucking flickering, anything like that. No vibration, no humming, nothing like that. So good. I told the customer I wasn't going to charge him for that visit. That's my fault. I should have. I knew better, and I knew what I had to do, and I just completely spaced out on it, and that's my fault. So got it up and running, fixed, good. Customer's happy. That machine's been down for a while, and they have not been happy about it. That's one of their better machines in-house because of the precision part on it. So it's what it is. All good. I'm glad they're happy. And we're going to keep an eye on that ball screw. If it makes it 6 months, I'll be happy. But we'll see. When I check backlash, now this is something that I was very curious about, because I always check backlash. Well, you should always check backlash after you do a ball screw, so you can reset the parameter. I checked backlash, and there was no backlash. And even repeatability back and forth of the clicks was good. I was like, okay. And this machine reads down to the millions. So I go into the parameters, and there was already no value in backlash. So I was like, all right, usually I'm not that good, but okay, whatever. Zero backlash, didn't have to adjust parameter, no value in the parameters. Good. That's a very good job, I think, in my opinion. So I think yeah, that's pretty much it for the week. That filled up the week. Next week, I have to go to Florida for a week. I think I can knock it out in a week. I have four machines, 4 or 5 axis machines that I need to pack for my customer in Houston. And then more than likely, I'll follow the machines from Florida to Houston and reinstall them in Houston. At least I think that's the understanding that I'm getting. So, Florida next week, pack 4 machines, easy peasy. They're all single casting 5 axis machines, nothing too crazy. And then probably about a week of trucking, relatively, I would say. And then I'll probably return back to Houston to start installing them, which should take me about a week and a half, something like that. I don't think it'll take me any longer than that. Usually I can knock out one of those in a day. They're really not that bad. We do got to have the OEM come in and unlock them because they have RMS units. Fuck's sakes. So we just got to get them placed, get them rough leveled, get power ran to them, and then have the OEM come in to unlock all 4 of them, and then get the fuck out of here. And then I come in and finish it up. So, a smooth job, honestly. It'll be a smooth job. So, looking forward to it. Now, motivation time. This is a part that I've talked a lot about, and that is diet and sleep, man. And I'm probably going to talk about this a lot because I, maybe with other people, have learned that diet and sleep is so fucking important for your body. And not only just your body, but your mind as well, man. Diet, I completely changed my diet about 6 months ago. I was on a completely horrible fucking diet. I wasn't on a diet at all. I was free reign, eating whatever, it didn't matter. And man, I felt like fucking shit every day. My sleep was trash. I didn't care about sleep. And, I woke up every day and I was like, why do I just feel like fucking shit, man? And I diet and sleep. So I changed my sleeping habits and my diet 6 months ago, and dude, what a fucking world of difference. Like, I can't even begin to explain the world of difference that it's had on me. My diet is I would say it's low carb, high protein, and I try to avoid sugar as much as possible. I don't eat dairy. I look at whole foods, and that's it. So anything that's considered a whole food, that's basically my diet. Fish, meat, fruits and veggies, yogurt. I throw a little bit of yogurt in. I know yogurt's not technically a whole food, but there are some healthy Greek yogurts out there that are pretty good for you. And that's my diet, man. I'll eat sushi occasionally, but for the most part, most of the ingredients in sushi, depending on what you get, are all whole foods. Rice, I mean, I stay a little away from rice because of the carb content of it, because I try to stay a little relatively low carb, but I don't, I'm not that strict on it. And dude, what a difference. It's fucking insane, man. It's crazy. My sleep, I started focusing on my sleep, getting minimum 7 to 8 hours of REM sleep. Now, if you don't know what REM sleep is, I highly suggest you go research it and try to focus on getting that at least 7 hours of REM sleep. And man, I'm telling you, you will notice a complete difference in your mood, in your body. I mean, you'll also see weight starting to drop off because you're not eating processed shit anymore. And your body is actually recovering every night because you're focused on getting at minimum 7 hours of sleep. And it's man, it's insane. So if you feel like shit, if you're looking like shit, and you're tired of it, diet and sleep, get those 2 things in line, and I fucking promise you, man, your life will change. It will completely change. And after that, it's just staying consistent, which to me has been really easy, staying consistent. I don't go out, like I don't party, so it's like I don't go out to bars and shit like that. So if I do get invited out, I don't go because I'd rather get my sleep, honestly. So I mean, it's a healthy lifestyle, honestly. It's you're not doing anything bad. You're only making yourself better. So Diet and sleep, man. Focus on it. Work on it. Do whatever you feel comfortable with, and I think you'll see a very healthy change in your lifestyle. So, thanks, guys. My name's Taylor. I own TG CNC Service out of Wisconsin. I just want to fix your fucking machines. I don't want to talk to you. I just want to fix your machines. So, thanks for tuning in, man. I really appreciate it. This has been a lot of fun for me. Obviously, I mean, I'm always laughing just talking to a screen, but it's fun, man. I love sharing, progression in my business and stuff. And if I can shed any kind of motivation to anybody out there, man, fuck yeah, love it. Thanks for tuning in, guys. I will see you when I get back from Florida next week. We'll see you guys.